Hello everyone and welcome back. For this worked exercise today, we will be doing a question centered around surface development. Now, for this question, we are shown an incomplete truncated elevation of a rectangular hexagonal pyramid. And what we're required to do is three things. One, we have to draw the given views, we have to draw the completed plan, and we have to do the surface development with the seam SS as indicated. Yeah, so what we'll do is when you look at this question, and let me see if I could zoom in on it so that you all could see it properly. We're given some dimensions in order to replicate what we're given. So we're going to start there, and then once we do that, we would have accomplished A, and then we have to draw the completed plan. So the plan is at the bottom here because, as you can see, this is correct. This is actually first angle projection. So since we have the first angle projection here and we know that this is going to be the plan, we have to draw the completed plan. And there are different methods to do this, because if it is that you do front, the end elevation and the plan, and you do your projection lines, you should be able to get all the points. However, the method we're gonna do today will be centered around utilizing the true lengths of the line. So you'll get a chance to see what that looks like in a bit. So let's accomplish A, then we'll move on to completing the plan, and last but not least, we will do the surface development. So I'm going to focus on that right now. So the first thing I want to do is, of course, we're going to start by creating our hexagon, and then we're going to move on to doing the top. And off the bat, I'm looking at all the dimensions that we're giving, and one of the dimensions that are standing out to me would be this particular 15 um distance measurement given here, this dimension given here, and this is the dimension from measured what appears to be the tip of the hexagon to the base of the triangle. And typically, where I would of course tell you all, hey, draw your vertical and horizontal plane when you're doing your orthographic views. In this case, we cannot adhere to the rule where I'm like, okay, you're gonna offset up 10 and you're gonna offset down 10. So we're just gonna complete these views and go ahead. So this is one of the cases where that would be omitted simply because of the instructions that were given in the question. So you can treat yourself to be flexible. So the first thing I'm going to start off by doing is, of course, switching from my my hidden lines to using my center lines. And I guess you could understand what I'm about to draw here, because I'm gonna draw a center line about here, and I'm going to click enter, and then I'm going to draw one horizontally, and then of course I'm going to align it in the center. Nice, awesome. Now once I have this, the next thing I'm going to do is switch from my center lines and actually switch to my construction lines, where I'm actually going to do POLY. So I'm actually going to construct a polygon, and the number of sides is, hey, our hexagon has 6 sides, so I'm going to enter 6. And once I do that, I have to specify the center of the polygon, right? But before that, let's just take a pause right now. If we look at the bottom here, it says specify center of polygon, or E for edge. So I'm going to type up E and I'm going to click enter. And the reason why I did that is because we were given the edge here, one of the edges. So I would like to plug that in order to what I would say is construct my object. So I will click here for the edge, and now you can see that, hey, I could actually construct. And now once I do that, I can say, okay, now I want to do 40, enter that dimension, hit enter, and boom, this hexagon was constructed. Now I'm just simply going to grab the center point, and I'm going to align the center point with the center point for my actual drawing. Yep, so I'm just going to highlight this, or move So then if I could just move it here. Okay, this is not highlighting, so what I'm going to do is highlight it. I'm gonna look for, I believe there's a parent intersection geometric center. Let's see if this gives us what we want. And I'm gonna click MOVE. I'm gonna click this. So now we have the geometric center, and I will just align the geometric center with the center of the drawing. EX, enter, enter. And now I'm gonna extend my center lines, at least for now. So this here is our hexagon, and just to make sure, we're just gonna, I just want to show you all, your hexagon is gonna have, oops, sorry, wrong one, dimension. Your hexagon is gonna have that exact 40 going all around it. Right, so yes, I use geometric center, and I don't think I'll be using it again, so I'll just take it off. I don't typically draw with it. Now what we're gonna do is, since we would have constructed the bottom here, I'm just gonna pull some dimensions, and awesome. So now that I have this, what I'm gonna do is I'm gonna copy this, move it, because I realize that I'm running out of space on top. I'm just gonna move it down, and let's say about here should be good for now. Nice. Now once I have this and I have all of the sides, what I'm gonna do is I'm gonna start to construct the top part, which is the front view. Yeah, and now I'm gonna use my construction line. I'm gonna go from here. Let me just bring that into view for y'all. I'm gonna come from here. We know that this is 15 up, and this is just like as a to get my reference plane. So I went up 15, and now I'm just gonna center it on that point. And then next, because we are going to draw the, and we're using orthographic views, you know what I have to do. I always say it, we have to use those projection lines to pull measurements. I usually recommend projection lines. If you wanted to, you could have literally measured the base of the object and simply use that. I like using my projection lines, and I would recommend it so that you get into the habit of having your drawings, the dimensions actually align. So from here, what we could see is we have those two endpoints there. So we have the 15 degrees in terms of distance. Let me just pull that so you all know it's real. So I'm going to grab here, here, and here. Yep, I'm gonna go. Now I have the 15. So now what we can see is we have a height of 70, what appears to be correct, 70. So construction lines again, not projection, construction. I'm going to, since it's for the center point, I mean it's a triangle, so because it comes from the center, and they said it's a regular hexagon pyramid, and if it's a regular pyramid, we know that it goes up to the point which is in the geometric center of the actual plan. So that means it's not tilting to the side, so we can actually take our true height measurement from the center of the object. So that's going to be coming up the center here, and it's going to be going up 70. I'm going to want to mark that off right there, right? Because we know for sure that that is where it's going to stop. So I'm just going to leave this right here, and now I'm going to take from that point up to the point of the 70, and then I'm going to go back down. And just so that I know, and so that you all know that we're operating with 70, I'm just going to, oh, I think I grabbed the wrong one. Right, I'm just going to use this so that we have a frame of reference. Awesome. Let's just leave this at this point. Nice. So at this point here, I would have constructed the triangle of 70 height. We have 15, and we have the 40 for the base. So that's good. But there's one more thing that we can't let go of, which is it's actually a truncated elevation. Alright, so that means that there's a particular cut, and you know that there's a cut here because you could see clearly based off of the outline that we have a slice through, and then the rest in the back here is either center lines or construction lines, giving you the actual pyramid effect for what the drawing is supposed to be, or where the lines are being projected from. So with the two remaining dimensions, so we have the 30 degrees and then we have the 30 height, what I'll do is I'll utilize that. So let me show you how I would use that. So I'm going to come here, I'll enter, I'm going to go up the 30 height, and when I go up 30, I'm going to go 30, enter, and then I'm going to come across here. Sorry, I'm just going to make sure that I know that line. In fact, just so that some of you can see. Nice. So point, I'm just doing this for your reference purposes. Once I reach this 30 degrees and 30 millimeters in height, sorry, I'm just gonna grab the marker just to show you all where it's at. Nice. And then with my using my construction line, I'm just gonna grab here and I'm gonna come up at an angle. Awesome. So I'm gonna go tab 150. If we're going to the right, it's 150. If we're going to the left, it's actually just going to be sorry, if we're going to the left, it's 150. If we're going to the right, it's actually going to be 30 degrees. Nice. And then once I complete this, so I would have gone up and would have come down so that I could actually see the cut where that 30 degree line cuts. And just so we know it's real, we're gonna grab the angular and we're gonna click here, and we're gonna pull that out. We're gonna click here as well. Then we had to get it to this somehow. Awesome. So I'll just use this here, and just in case this was a bit confusing, because of the properties of lines, if it is that I take an angle, let me just grab this here. Even though I took it from the base, if I take it from, did I do the line? Okay, let me just draw it over again. Let's just say I have a line coming from about like here. Hopefully it's there. And I take the angular. I know you can't take it from, no, it's not doing it. So what I have to do is I have to move you across to about here. Nice, reveal it, and then I'll just grab this. Nice, just so that we know it's 30 degrees. Awesome. So what I was just saying is that because this line here and this line here was parallel, I could have just used, and this line here was intersecting both of them or cutting through the plane, the angle would have been equal. That's angle theory. If it is that you want more information on that, you could check on one of the videos. If it's not up yet, it will be out eventually. We're prioritizing this one. So let's go on. So at this point, I would have constructed everything that is needed to proceed. I'm going to grab the outline. I'm going to go from the bottom. I'm going to go over my drawing. This is just my preference. I wouldn't really, just remove all of my scaffolding or my construction lines. I would usually just do it over. Draw over it, or just simply convert the line to outline. Nice. And once you reach this particular point, there's one more thing that needs to be completed. This, from this point here to here, will actually be a main object outline, simply because it's a pyramid, so therefore all the edges have their all the vertices have, for the base itself, or corners for the base, have corresponding lines coming up to the point of the apex. Yep. So that is the completed part of how we're supposed to recreate this. Now inside of here you will see these squiggly lines, and don't be fearful because some of you may not have seen it already, but these squiggly lines just simply represent the incompleted part of the drawing. So we know that there's lines supposed to be coming in, but that incompleted squiggly line says, hey, it stops here. At least what was drawn stops here. So we're gonna Now answer the question B, which is to actually just complete the plan. So the first thing we need to do is, of course, marvel at our awesome work that we did so far. But we're gonna go back in our construction line, and if it is that we're using the true line method, which I would have indicated in the beginning, we would actually need to have a better understanding or derive our true line based off of what we were given. So first you'll grab a circle, and then you'll go from here to this, from the center to the end of the hexagon. And what you'll realize is that at these particular points, it's always max distance from the center. So therefore, our true length for any one of these corners will be at this max distance. So if it is that we wanted to transfer that onto the drawing itself, I'm going to EX enter, I'm going to extend it. I'm going to extend this horizontal line. If we wanted to do that, of course we will take from this point here, carry it up or project it up. I'm going to leave it in red for now, and then we're going to project it to the center point. And the reason for this is, if it is that we were supposed to rotate this, the orientation of this view just ever so slightly, this line here, the true length line, will actually be the max distance that one of these edges will align with, which will give us the true length. Just letting you all know. Yeah, so even this one at this distance is not the true length, it's just simply from the perspective. It's really from the perspective once we, or if it is that we had the opportunity to rotate it. So that's enough for the theory. Let's get back onto the construction. So one of the things that we have to do at this point is, since we got the true line, there's one more thing that we need to do, which will be our projections. And after we do the projection, or grab the projection lines coming down, so let me show you. This is going to come down here. I'm going to do some vertical projections, and we also have this line here, this point here coming down at 90 degrees. We have it cutting through everything. Right, so as you can see, we would have points coming in for here and here, but we don't know exactly where the points will be at this center point. And this is where or where our corresponding line will be for this, for the center line. And this is where the need for the true line comes in. So what I'll do is I'll just simply grab this line, project it across so that it hits the true length of the line, and then I'll project it down. I'll just pull it straight. Nice. Let me just make sure. Right. And in a similar fashion, what needs to happen, just like how we had this circle here which gave us the true orientation when rotated, what we'll have to do, or the true length of the line when, is simply just, you could either grab a circle or you could do this with an arc. Let me do it with an arc just for simplicity's sake. I'm going to come from here, I'm going to meet that line, center start, and I'm going to do the end, and then I could simply just do my center start again, and I'll just do it in the opposite direction so that I get where the point is supposed to be. Shift, let me just get that. Nice. I'm going to get where the point is supposed to be for the other one. So now that I have this, I know you're wondering, but still, I've gotten to this point, but I still don't know where the points are at. And this is where the next part, in fact the second part of finding those particular points come in. As long as you pull down your lines, we usually find those particular points by finding where they correspond with the construction of the pyramid. And if you know that it's a pyramid, you know that it starts from the outer ends go in, or the outer edges go into that particular point. So if I was supposed to replicate a line doing exactly that, it will come from here and go to here. Same thing with this. So this will be one of the faces. Then of course I'll have a face going here, and vice versa. And once I do this, I would have actually completed a line from all of my edges going to the apex. So now, right where these lines intersect, where my orange lines intersect my red lines, are actually where my points will be. So let me in fact, let me change it to my green one, my green construction, and let me enter those points. So the first one will be here. These were the ones that we worked so hard to obtain. Second one will be here. Then we have one here as well as one right here. Awesome. And remember, this particular line was for our construction using the true length. So therefore, this one here is the one needed. And if you always need to know, you could always look at the drawing above, say, hey, this is in line with what we're looking for. So the line comes from this particular point, come here, cut in, and if we pull it vertically down, this is where it is. So which means here, P-O-I-N-T, is where we need to mark off that, and right here as well. Awesome. Now once we have gotten to this point, it's okay to just simply click away and complete the drawing using your main object outline. I'll enter. So I'm gonna go and I'm gonna click all of the points, and 1, 2, 3, 4, 5, 6. Awesome. But we're not done yet, because these are actually outlines. We know that, hey, there's an edge coming from here to here. We know that there's an edge, a tiny little edge coming from here to here, and then there's another one going to be coming from this here to right here, and then there's going to be one coming from here to here. Then there's another one coming from here to here, and last but not least, we have one coming from here to here. Awesome. Once we've gotten to this point, we're pretty much finished, but just to add some perspective to the drawing, let's go above and beyond, shall we? So we're going to actually grab our hatch lines. We're going to hatch this, and let's see if I can get it. I know usually when I'm doing this it's hard. Nice. I'm gonna do this. Wait. Alright. You know what hatch lines are supposed to be like this. I'm just gonna select all these spaces. I could have simply turned off my layer. Oh no. So some of them aren't coming in. Let's see if we can get a space here. So why am I not getting it? Okay. This space here, this space here, this space here. This space here. For some reason this one here didn't do it, so it's okay. I will just click everything. I will delete it. I will then let's see, I will turn off, because I really and truly just want those hatch lines to be good. I will turn off my center points. I will turn off my orange construction lines as well as my red projection lines, just so that I have a nice decent space. I'm gonna hatch. I'm gonna grab those lines, click on the inside, enter, exit, escape, then simply just turn back on all of the layers. Nice, and all of the layers are back, so we should be good. So that is just a hint. If your AutoCAD just refuses to hatch because it can't find the boundary, simply just remove the unnecessary lines so that AutoCAD doesn't have to figure it out. Simplify the drawing and then hatch. Awesome. So once you reach this, let me see if I could turn this to no, that is confusing. I would like it to be in blue. Let's put mine in blue. Awesome. Nice. So once I have it in blue, so we can see where our triangle has been cut here, and everything is well. We making sure that the angle is not exact. Some of the sides. So this is complete, and this brings us to the end of the B part of it. So now for the C, where we're going to do the surface development. So now we're going to come across and we're going to observe this drawing here. And for those of you who don't know, let me just touch on the point. Your surface development is like opening up the object or unfolding the object, like how, let's just say, like a toothpaste box. If it is that you cut it on one of the edges and you open it up and you see the net, that is what it essentially we aim to do when we do the surface development. So for this method, what we're going to do is we're simply just going to, since this is not a box, this is a, yes, this is a pyramid, or a more or less like a triangular base type of structure. We're gonna grab this, a circle. We're gonna construct a circle at these particular points. So I'm gonna start off by doing one, sorry, delete. We're gonna start off by doing one, C, enter. I'm gonna come from the end here. I'm gonna open it up to about this point here. Nice. So we're going to start off by doing it from along the true length of the line, because if it is that we're doing the surface development, we don't want the perceived length, we actually want the true length. For everything else, I'm simply just going to pull the lines across until they meet the true length of the line, so that we know where they exist, as well as this one as well. Awesome. And then we're going to do the exact same thing. We're going to take our center or our circle. We're going to circle the point here. We're going to do circle to point here, and then we're going to do circle to point here. Awesome. So now that we've done this, we kind of have an idea of, okay, these points here exist somewhere on the surface development along their corresponding lines, and that's okay. We're going to have to figure that out, and the question is, how do we figure it out? So since we know that we're unfolding the object, each point is going to occur at every edge of the base, meaning every 40 millimeters. So therefore, all I have to do is create that 40 millimeter distance. I'm going to go center, start, end, enter, click that again. I'm going to go here. I'm going to go 40 tab. Oops, sorry. I'm going to go center, start, and let me just make sure I have a center, start, end. I'm going to click here. I'm going to go 40, enter. I'm going to click from here. I'm going to cut. Nice. So that's one. We have to now repeat this 7 times, but there's a trick. So let me just go over this. There's 6 faces in a hexagon. 1, 2, 3, 4, 5, 6. So there are 6 faces. However, the question talks about the SS line, and there's a seam here simply because it's like when we open the toothpaste box, but we cut it along one of the corners. If we cut this along one of the corners, we would have cut it along here. But if you cut it in the center, what you're going to get is an extra face, or one face divided by 2, which would mean 2 half faces. So we have to compensate for those 2 half faces. So just to be you know, preemptive, or at least plan ahead, we're going to do 7 divisions, and then the first and the last division we're going to divide it by 2. So when we divide it by 2, it's going to be on either, it's going to represent either end of this SS line. So I'm just going to forego drawing any line here right now, and I'm going to do my divisions, and I want you to do that as well. Alright, so I'm going to come here. We do that by coming from the next point. We're going to hit here 40, enter, then we're going to cut. Does that look like 40? Then we're gonna, let me just check it out, because that looks a little bit over 40. Oops, I did not trust my construction, so that's my bad. It is actually 40. So now I'm gonna click here again. If you want it to look neat, you could just bring your center, start, and close to where it's supposed to be, around here. Then you could do 40, enter, and then you could do a nice little cut, and then you move on to the other one. So I would have done 1, 2, 3 divisions. I have 4 more to do. center start end here 40, cut, nice, center start end here 40, cut. Awesome. So it's just showing that we're bisecting going along. How much is that? 1 2 3 4 5 6 7. Two more to do. One more after this. 40, enter, cut, nice, and then the last one, but not the least one, of course, 40, enter, done. Alright, now once we do these divisions, it looks like some type of Ferris wheel type thing, but now the next step is to actually take those key points and lead them straight to the center of our circle. So you can go L and take a touch, that, enter. We're gonna go from this point, touch the center. We want to make sure, see, we want to make sure that we're getting those stuff on the center point and not just snapping it anywhere. L enter from this point here to the center to the outside, and enter from this point here to the center, then to the outside. So now we would have completed these faces, and next what we'll do is simply just draw a line from each one of these to the points. And I'm just going to throw out a question. What do you think these lines represent? If your answer was the base, then you're correct. These lines should all be measured up at, oops, this one did not meet it. See, there we go. Right, but each one of these lines would measure up, and this one is, I know it wasn't there. Nice, let's get that at that point. So now they should measure in at 40. Awesome. So each of these lines represents one face. So therefore the base length of it should be 40. Hence, coming in to the point, we'll actually have the full face if it is that this was an entire triangle. So now, because remember we talked about the SS line, so we're going to start and we're going to end on this particular line right here. So therefore, let me just go text TEXT, enter. I'm just going to put here, I'm going to go S, enter, escape. I'm going to grab one of you guys. Let me just turn you all into main object outline. Enter. I'm just gonna grab you. I'm just gonna rest this one. Let's see if I can rest it out here. So nice, and I'm just gonna put this one here, and these are going to be representative of our SS line. So let me just put this here. Nice, awesome. So that'll be solid regardless of what we do. So we have our SS line existing here. So now let me just copy this. Our SS line is now going to be from the first face, and it's going to end on the last face. So next, we know that it's going to be half of the length, but we did 7, so therefore the first and the last one, we're going to divide them by 2. You can either use your object snap. I'll use my object snap for this one, where I just grab the center and measure it inwards. Make sure that hits the center there, which is good, and then I go from here to the center of the last one, which is right here. Let our object snap. So now I can grab my main object outline, and I'm going slow enough for you all to follow me. I'm gonna grab it from the center, then hit the end. I'm just gonna go around and solidify that. I would have done it in the construction just so that you all could, see that okay, these are the solid lines that we're gonna be using. So this is the actual span of our base. Awesome. Now once we have this, we understand that it's short, long, 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 short, which will be short, long, 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 short. Awesome. Now once you finish this, the next thing that we have to do is you actually have to plot. We did the outer one, we have to plot the points for the inner one, and the inner one is a bit more irregular, which is where the circle comes in, because we know that the concentric circles, meaning at each point they correspond to a particular point on the actual cut, and this is where we're going to utilize that. So for the first one, get your points ready. So I would recommend probably like changing the color of your main drawing line to, I just say I will use my orange one because I like orange. It's not my favorite, but it looks good on AutoCAD. So I'm gonna go point. I'm gonna take it. Now remember, look at where the first point stops. It stops on this circle here, and then it passes up. It's gonna be here because I know I'm gonna start here. So remember, the SS line exists on this particular plane. So it's going to be here, and then the next one is going to be right here, simply because what we're mapping out is, let me just show you all on this. So the first SS line is going to be here, the second one is going to be right here. Right, so those are the 2 points that we just did, and we're going around in a counter. Well, I'm going to go around in a counterclockwise direction. So next we have to go up a particular line. So we have these two happening on this line, and then if we follow this particular point up, it reaches right here, and if you follow it across, it's the next in line. I want you to keep that in mind, because since we know that we're going to go the next in line, if we know that this cut, the next one we're going to do, is going to be the next concentric ring, then we just have to go next sector and up in line. So hope you'll understood that. And there's a thing that happens here. So if we know that this exists, because that's this one here, there's something else. These two are actually in line. So therefore, if I follow it again, the next one, even though I'm going up by the next sector, is gonna be, let's know, POINT. It's actually going to be on that same ring. So again, let me just show you from right here, because the first one and this one are in line with each other, they are also going to be on the same ring. So even though I went up, it's on the same ring. Now moving along, now we're going to go down the actual rings, because we just now we was going towards the center. Now we're going to go away from the center. So since we've did this one, we're going to go back here, then we're going to go back across here, and we know that these two last one are going to be on the same ring. So you have to go down a ring, same ring. Right, so we're just going to follow through with that. You can take this step by step and do each one and follow it and trace it, for those of you who need to, until you build up the confidence to actually, understand your drawing to the point where you could just interpret where the points are going to be. And it's always good to check over with regards to that. So once I have these, at this point we know that we're going to create all of these in a solid line. We did our construction in the points. So now let's go main object outline, and we're going to grab the line from here, we're going to cut it in, we're going to go those two, then we're going to go up, and then we're going to go straight, and then we're going to go straight, and then we're going to go back down, which is this one here. Awesome. Then we're going to go right here, then we're going to hit this line right here, and then we're going to go back and escape. So once we have this, we can actually see our surface development taking place, but there's something missing. I'll tell you what it is after. But right here, let me just grab this. Right, so now what we could do is we could just label our SS exactly where our where our SS line will be. Seam, it should be one, will be, nope, that snapped. So one would be from right here to right here. Nice, let's just label that there, and the other side would be, won't be here. I find that overlapping with the drawing, so I would remove it and do it again. So one would be right here and the other one would be right here. Awesome. So those are your SS lines, or the seam of it, which would have been split for that particular face. And like I was saying, there's something missing from this for us to understand it, because if it is that I come here and I turn off my construction lines, I don't know what that is. I don't even know what they should represent. So for this example, we would use our hidden lines, our dashed lines, dash hidden, same type of lines, but I want to use those now to kind of represent those seams in between our faces. So I'm going to zoom in just to make sure that I have it crisp. Enter. I'm going to go up and enter. Point. Point. Next one. I'll enter. Point. Cutting it close here. Point. This looked like it went a little bit beyond, so I'm gonna grab this. I'm gonna grab this. Gonna bring this in a bit. Awesome, nice. Then I'm gonna element, and the reason why I could have done that with that is because it's on the outer part. So as long as I bring it in, it will just align. There was no construction that depended on those two particular points. And I'm just going around here, just looking at it and just lining up what needs to be lined up. So again, straight from here to here, and boom. Awesome. So now if I turn off my construction lines, now we can clearly see that these are all like crease lines, so that once we fold it along these particular lines, we would actually have our full surface development, which would be going around this particular object. So that is actually pretty cool. I like that. Awesome. So now this is it. We have everything that we need. We did from the given views, the completed plan, and we also did the surface development of the pyramid with the truncated pyramid with the seam SS as indicated. So we did that, guys. It was a good example. I enjoyed doing this. Most likely I will post more videos on surface development in the future. Remember to turn on the notification bell icon, click that. Also like and subscribe. Let me know in the description if it is that you have any questions, or there's anything at all that you like to like me to improve on, or just simply let me know that you're watching the video and where you're watching it from. And yeah, I hope that you all enjoy the rest of your day. Peace.